Hi everyone, in this video we're actually going to look at how we can do la voûte de Lefebvre from Material Design. So they have done that structure in timber with a lot of like different hexagons and honeybee sort of shape and form, and we're going to look at how we can use that pattern and apply it to a lot of different surfaces and geometry. So this purpose of this tutorial is more for studio architecture, so it doesn't meant to be like for web or for things like that. So we're going to see that it might be heavy, so it's really purely to render and then eventually to 3D print parts or laser cut parts, but it's not really for web. So I think it's important to specify because there's a lot of way you can do it and a lot of way you can model it, and the way we're going to see it today is for this sort of purpose. This is what we're going to model today in this tutorial, and this is sort of the script. So if you're a patron member, you'll get all the files, and we're gonna end up with also like a AI rendering of it at the end. So let's jump back in. Okay, so the first things you want to do in architecture overall is always have a sense of scale. So it's always good to have a little figure in your Rhino model where you're able to sort of understand how big things are. So it can be just something just download and sort of play with, so you get a good idea of how big things needs to be. Just make sure they're on the ground. And then another thing that is always good to start, if I go into top view, get a bit of a shortcut here. So it's just drawing a ground floor plan, okay, like not a floor plan, a ground, sorry, in which your person is sitting on, and sort of gives you a bit of a sense of scale. Okay, so this is the first step. Then the second step we're going to do here is we're going to define our geometry and surface. So I'm just going to do curve, a new layer, and I'm just going to do curves, and then I'm gonna go in the right view. So you can go here and then view and then change the view here. I'm just gonna go and sort of model using the spline a series of lines to define my geometry. So again, you see how I use actually a human to define how big space could be. So for the moment it's quite rough and it's okay. It's just to be able to understand what type of space I could create from those. And then I'm just gonna move them around. This is quite nice, I like that type of things. Okay, this one is quite tight. But anyway, you can adjust your shape as you wish. I like working in sort of elevation, so you can see that's a nice series of space. So you can see, so if I go, so you can see here, if I have my ground here, I'll just like having sort of a space that you can create. You still have a bit of space in between those elements, and then this is sort of pushing down, and then this one here is just pushing up, and then we have another one that is pushing down. I think it's just create that really nice flow between those curves in elevation. And so if we go back to the perspective view, what's important, and here we go. So one of the things that I should have done is when I worked, I should have project everything. So if you draw lines on the right view, you should tick project, so you're sure that everything will sit nice and flat on the plane. But because I didn't do that, I have this sort of effect, which is not the end of the world. What I'm gonna do is I'm just gonna bring everything back to the projected plane. So to to do that, set point, and then I can pick my plane. So you can see here, that's the Y direction. So that's the Y plane. So if I tick on set Y, it will set everything actually along the X on that Y axis. So I need to go back, and instead of set Y, I'm gonna set X. And then X now is just sort of set it nice and flat on that line. So I press X, I click, and that's it. Okay, so now I got my shape and form, so I'm just gonna move them around to create that 3-dimensional feel. And now I have my loft. So what I'm gonna do now is actually, I'm not gonna do anything else in Rhino for now. I got like sort of the flexibility I want from Rhino. I can still move my points around, change them. But what I'm gonna do is I'm just gonna jump here in Grasshopper. So the first things I want is I want to create a curve. So I'm setting multiple curves. I'm setting my curves in the right order. And then I'm gonna create a loft out of those curves. So the loft that I create is actually quite cool. So you can start already to see the shape and how it could look like. Okay, so what I don't like with this shape is it just doesn't go down much. So I may just bring this one a bit more extreme. So then we almost touch the ground here, but you still have some space here to move around, or we can refine that later on. See, you sort of want to have still the scale so people can still go through. Okay, so this is my form and shape, and then the second step is an hexagon. Great, hexagon cells. So I'm just gonna select my hexagons, and there we go. I have my hexagons on top of my surface. Now here I can define how many division. So if I select, let's say 35 for now. I have quite a lot of hexagons. I have actually 648 hexagons. So it says here, you can see it. Okay, and then sort of the second step here, or like the next step I guess for this one here, is to create an offset of that surface. So you remember we want to create, one is the hexagons, and then on top we have a circle. So we want to create a circle. So what I'm gonna do is I need to offset my surface. So I'm just gonna offset it, and here I'll give it an offset value. So let's say this is fairly small scale, maybe 100 mil. So again, if you're not too sure what to write down here in terms of dimensions, always make sure your units here, what does it say here? If it say millimeter, here in Grasshopper it's going to be millimeter. So 100 mil, 10 centimeter, 0.1 meter, and this is what we get. So we can start with 100 mil and we can see how it feels. Might probably gonna need to bump it up. Knowing the scale of it, it's probably gonna be likely to be 200. Again, it's always good to keep it as a slider, because when you talk to the structure engineers, you can sort of have that as a slider. So then when they come back with their calculation, they can tell you which number slider you need to put in there. Right. So what I'm gonna do here is I'm gonna create. So we have the hexagons the bottom. If I bring back the reference, we have the hexagons at the bottom there, and then the circle at the top. So what I'm gonna do is I'm gonna create my circle here at the top. So what I'm gonna do is I'm just gonna do scale. So I'll use a scale one here, and then I'm just gonna select my hexagon, and you can see it scaled the whole structure. But if I bring the center back to this centroid of that geometry, then I start getting each hexagon scaled on their own center. So if I here put 0.6, so if I take it here 0.6, I can actually change the size of my hexagons. which is quite good. Now, what's nice is the hexagon, but what we want is we want circle instead of hexagon. So the way we could do it, we could actually explode that hexagon geometry and extract those vertices. So vertices are actually point, and I'm just gonna do an interpolate, and I use those vertices to actually create a circle. One thing that you might notice is the curve is going through all those points, so the circles are not really nice. So there are ways around it. I try with NURBs. One challenge with NURB is that it creates nicer shape because it doesn't go through all the points. It's NURB geometry, NURB curve. But it sort of need to kill the duplicate because there's 2 points here. So if I go into my point list and I look at my points here and I change it to, let's say 50, as you can see 6 and 0 are on the same one, so there's double points. So it will insist on that point and it will just make sure that it sort of goes through, so which is not great. So what you could do is you could actually call duplicate, and that will get rid of the point here, the extra point, and then you can plug it back in here, and you can see that your NURB is not quite close, so you can set it close and it creates some nice circle. Now, one of the challenge, we're going to look at it a bit later, but one of the change with this one is to create the loft between the hexagons and the NURB. It doesn't really quite know how to join them, so we might need to find a way around it. There's ways around it where you could create another loft and things like that, but we just need to sort of find a way to have those lines. So we could definitely go through that, but we might need another video to deep dive into this. So for now, we're just going to focus on this one here, and we can just sort of adjust a bit the core side. We could just do uniform spacing, so that will sort of help a bit with the overall shape. Spacing is not quite there, and you will see like according to your geometry, it might be good or bad. But so that's it. So now we have instead of our hexagons, so if I turn off everything, the preview, we have circle at the top, so very similar to what Matter Design had, like the circle at the top, and then we have our hexagon at the bottom. So what we're gonna need to do now is actually joining this two. Okay, so one way we could do it, we could actually create a loft between them. So what I always like to do is using merge first, just makes things a bit cleaner, and we're gonna merge those hexagon with those curves here. Now you can see there is, and this is why it's always good to go through a merge first. You can see that one list is grafted, so it's different paths for each of those circle, and this one is flattened, so all the hexagons are there, but they are in one single list. So what you need to do is you need to graft this one. Right click graft, or you can also use graft here and plug it in as a component, and then put it here. I will use probably the right click graft, but that's, you know, when you look at the video, you're like, oh, it doesn't work. Why it doesn't work? So I'm just trying to make it a bit more clear, like this way. And then another things that you probably want to do here, doesn't matter because the path, you can see the path here is 0, 0, 0, and then underneath is 0, 0, 0. So the path is similar, so they actually match. But if they don't match, you might want to right click simplify. When you simplify, it goes from 0, 0, 0 to 0. So simplify the path. So you can simplify or not. And now that I have 2 values in each list, I can actually create a loft. And there we go. And now I have a nice loft between my hexagons and my circles. So it creates some really interesting pattern. And then you can potentially stop here, or if you want to push it further, you might want to actually join that circle to the original hexagon. So a way we could do it is we could also do another merge from those hexagons and those circles. So curve to hexagons, and again make sure that it's graphed. So I'm just gonna put this one here, and then I graphed those ones. Now they are in the same list, and then I can copy paste my loft, create a new loft, and then plug it in. And now I have a nice surface that is sort of look flat here at the top, and I also have this sort of interior one that is really nice. And then another step you could do to make sure you have a closed B-rep for each of those elements, because if I merge now this loft and this loft, and I join B-rep, I will create one B-rep out of this geometry. But if I look at if they are closed or open, it would say that it's not closed. And the reason it's not closed is if I bake this, geometry, bake that, and then I isolate it, and I'm just gonna turn off my visibility graphic. That's sort of what I have. And I don't know if you plan to 3D print, but this is not gonna 3D print because it's a B-rep, but it's missing basically this surface here, from here to here, and to go from this hexagon to the bottom hexagon. So very simple, we could actually do it here. So we're just gonna do going from this hexagon, so we can select this hexagon here, to this hexagon. And now I'm joining basically these two together, loft, and now if I plug this one in, it will create a true polysurface. So now if I bake this one, I bake it, the geometry, and I turn off the preview here. One is a closed polysurface and the other one is an open polysurface. So this could be sent to Cura or sent to any 3D printing you have, and then you can just 3D print the speeds as you want, and you could just build the model all together. Whereas for this one, it will be tricky. Okay, so that's something to keep in mind, to have some nice clean. And the reason at the start of the video I was saying that it can be really challenging in terms of web, for example, if you want to send it to use Shape Diver or a tool like this, they will not like that, because here you can see that the profiler is giving me like 500 milliseconds, which is huge. And it's okay for architecture and for sort of design or quick iteration or test a script and then maybe change, you know. It's like testing an idea, it might not stick, So it's an easy, quick way to get through, but it might not be the best way to get through the whole process. Okay, so keep that in mind. This is really big in terms of processing. Also, to see those things, you can just go in display, and then here you can see the profiler. Here, profiler. Okay, and it gives you what slows you down. So one thing that I like to do is to just turn it off when I manipulate those things. Also, you can see that now everything I highlight is showing. But if you want to remove that, there's this tool here. So then now if I right click and preview, it will always preview this as the geometry. Okay, so now that I have my geometry here, I'm just gonna show you back everything, and I'm just gonna delete that geometry. Okay, so I have my geometry now. What we want is we actually want to add an attractor point to manage the size of those circles. So one way around it would be to actually change that factor here. So what we need is like not one factor for scale for all of them, but actually a lot of different factors for a lot of them, right? We have 648 hexagons, so we need 648 values. One way to do that is to use evaluate surface. So what evaluate surface will do is it will actually select. So we're gonna select the top surface because that's where our circle are. And then here for the point, we're gonna use an empty slider. The empty slider, put it here, and then here, we're just gonna reparameterize. That's very important. If you don't reparameterize, you can see that I move that point, but it will not quite follow my geometry here. It looks like it's doing actually a good job, but usually what happens is like it doesn't really follow always the geometry. And if you change that to push it a bit further, it might actually sort of screw a bit your UV. So one thing around it is right click, reparameterize. Okay, so now we have that attractor point, and now all what we have to do is to find out the distance. Again, there are new tools now, plugins that actually this is a very old school to do it, but it's sort of like, I guess, one of the original one. So what we're gonna do is we're gonna calculate the distance between that attractor point and the center of each hexagon. So I'm just gonna put it here. And so I have 648 points, and there will be like a distance to that specific point. So every time I move that point, it will measure the distance. So it's very efficient, and it works quite well. So it gives me all those distances. Now I'm gonna have to change those values into something that the scale component will understand in terms of factor. So I need to translate those values in terms of factor. So between 0 and 1 basically. So I need to use a component called remap. Remap value, you put the value here and then you set your bound. So bound will measure the min and max value of that list. So here, for example, the closest point from that location here to the center of an hexagon is 291 millimeter. I move it around. Here it's 63 millimeter. Why? Because it's very close to it. But then the maximum distance is 11,600 millimeters. So it might be just, I don't know, probably somewhere here. Anyway, that's how you measure the bound, so the min max value you have, and that will be automated. So we're not gonna worry about it. What we're gonna worry about though is making sure your domain is correct. So I'm gonna construct the domain, and as we said, the factor here needs to be always between 0 and 1. So what I'm gonna do is I need a slider. Let's do 0.1. Right click. And then I can edit the slider. It's a bit of old school to do it, but that's okay. And then here, I'm just gonna do min, max. Okay, that's great. So we have from 0 all the way to 0.1. Okay. So now I have a value slider. And so basically what that does is it recognizes the bound, and it will say, okay, 35 will be a factor of 0.1 and 14,700 would be a factor of 0.9. Okay, so this is how you actually can give a factor to your value. And now if I look at my numbers here, they are remapped, all those distances here, and are remapped from 0.1 all the way to 0.9. So they're not going to be a value that is bigger than that. And then I can basically use those values to update my factor. So now I can delete this one, and you can see that the closest I am to my attractor point. So where is this attractor point? Here. Where is it? Here. So the closest I am, the smaller the circles are. And then the further away, the bigger the circles are. Okay, so if I move that around, again, it's a bit slow, and I'll show you why. So here we go. So then now our point is here, and you can see that it changed factor. So it helps automate the process, so you could go, you know, and have that attractor point to drive some of the design. If I go in static view. Okay, so that's how you could get it to work. So fairly easy. And then when you have this, what you could do, what I recommend you to do is right click on, select all that, and then disable. So by disable it, and then maybe select this one's, maybe just this one's actually. Let's have a look. Yeah, I mean, this one's would be probably enough to read the geometry. And now if I move my point, it's going to be way faster, and it will give you a good outline of what is happening here. And the processing power would be, it would be way faster and easier to manipulate. Okay, so this is one way to do it, and that's it. And now we're going to look at how we can visualize that into ComfyUI. Okay, so all what I've done here is I just right click here and I bag my geometry onto the geometry layer. I kept my guy here, little scaled model here, and then I just have my Grasshopper script here, and then I have ComfyUI here turned on. So this is the same script as the one I've done in the previous video. Nothing new here. And what I'm gonna do here is I'm just gonna share my screen. So I'm just gonna go. So you might have noticed, but I am using the web UI, despite the fact that I have the desktop one here. One challenge that I found with the desktop is that it's actually tricky to somehow those share screen don't work with with this one, which is a bit frustrating to be honest, but it is what it is. Okay, so image, I resize it. Okay, so I don't need those components here. So I'm just gonna delete those components. So here we go. So image, it goes into resize. Don't need the segmentation because I'm not using it. Okay, all right. So let's have a look at that and see what comes up. So maybe let's focus on the prompt here. Raw photo, perspective. Nah. Architecture. Photography. I'll just remove the overexposed. Organic formed. Organic formed. Modern is just a bit of a weird word. Pavilion. Let's put it in the middle of a park. In Oslo? Allez. Oslo. And then material, we're gonna just say light timber. Light timber structure with parametric panels. Parametric plants. Now let's remove the plants. Let's remove this. And then this time maybe we can do. Oh, I can keep this. And let's see how it goes. Surprise. My canny is not capturing much, but the depth is capturing some really nice ones, so we'll see. Somehow the canny doesn't capture those lines here, which is interesting. Might actually be a really nice shot if we get it right, because I like that. I like the composition here. So we have like, this is all like sort of sky, and we have the building in between. And then here we have something else. Let me just have this sort of geometry there. Let's see, because I'm not too sure if it's gonna get it quite right, but sometimes, you know, when you think about the volume, sometimes you always want to capture the full extent of your design, and you want to show everything, but sometimes it's good to just sort of like, I don't know, hide it and just have it just a portion of it. So then, and I like that, and you could use infill eventually to complete that proportions. Nice third. Yeah, so quite interesting results. So maybe, yeah, this is a bit muddy. So let's see what comes out. But it still capture quite good form. I think it's because of my depths. My depths capture it very well, and then it just sort of let go on the canny. Actually, I really like that framing. I think it gives some, you know, it gives some really nice space. The top, like here, all that area here, and then there's, you know, a bit of a contrasty darker element at the bottom, and then you have your main geometry in there. Oh, whoa, okay. No, interesting. Not as realistic as the previous one somehow, but there's some interesting stuff in there. Okay, let's see what else we can get out of this process. The timber though, timber is quite interesting. But again, our sort of hexagon disappeared. It's just sucks. It's been really simplified. It's a bit of a shame because we had some nice parametric pattern that's got reduced here, but you know, and then somehow this here, like it's sort of, it feels like out of scale compared to this. So I'm not too sure what is happening here. This part here, I don't know what it is. Like, is it a lake? And then it looks like it's a lake, and then there's some islands there and there. But then it feels like, it almost feels then the side is like this in section, and then you have your building somehow going down, and then the view you have is, you have this footpath, and then you sort of see super far away the island. You know, this, maybe that's what happened. And here you have the island we can see here at the top. I don't know. But again, can you capture it? Not as well. I'm wondering if you ever need the canny. I think maybe the depth would be just fine. So you can see the depth is sort of capturing here. It's capturing those circle, and you look very close on the inside here. I don't know if you see it well on the screen, but you still feel like those hexagons are here. So that's what the depth is capturing quite well. So I think that's a good thing. And if we look at the canny, it feels circle, and here it feels still hexagonal, but yeah. Okay. Oh, interesting here. But again, we lose some of the depths. You know, here we get a nice, I think it captured that part very well, but the inside is still very circular compared to our hexagon there. So it's, maybe it's because of the pattern. Maybe if we look at, we add a bit more shadow or change a bit of view, might help a bit more with this sort of hexagony feel. But yeah, that sort of probably needs a bit more testing. But I think it's interesting to see it coming to life. That's it for today. Thanks for watching. I hope you enjoyed this video. So it was really interesting to see how we could sort of model something fairly quickly in Grasshopper, get some ideas, get some testing, and then sort of visualize it straight away into AI and see how robust that workflow could be for iteration. Again, we saw like there is some flow in on the AI part, so there's some data that are missing. So it's probably worth spending extra time to just figure out how those, what are the right angle to capture those data, and maybe like having closer shots could be also quite good. But it gives you a good start to explore and iterate. I think the result is quite promising. So that's it for today. If you like the video, yeah, like it, comment, tell me what you think, tell me if it's useful, tell me if like you could use it for studio, or you could use it, I don't know, to talk about a concept you have. And I think always computational design and AI are sort of like quite close and can be really powerful end to end. So until the next video, enjoy exploring and see you next time. Ciao.